All right. Period 5. Hannah Lannon. And Jenna. Okay, what we want to do is just a brief review of what we covered this week and take any questions that you guys might have, and finally talk about what next week looks like. Hey, Angel, good morning. All right, if you guys have any questions at any time, just jump in. Using the messaging thing, the chat, I don't always see the chat icon pop up, so just unmute and ask whatever you need to ask. This shouldn't take very long at all. I'm really more interested in hearing your questions than I am interested in sitting here talking for 45 minutes or an hour. Let me close the door real quick. Okay. All right, can you guys see my classroom on your screen? Is that getting shared? I don't think it is. I need to present like this. Okay, can someone unmute and tell me if you can see my screen?
I can.
Great. All right, so this week, 11.9 through 13, we covered phase changes, which was started last week. Last week, we started talking about thermal transfer and energy that's stored in matter, that solids, liquids, and gases are all phases, and those phases are representations, they're manifestations of kinetic energy, that as molecules move, we have temperature. So if the molecules are moving faster, we have more temperature. If the molecules are moving more slowly, we have less temperature. That we go through changes of state because of molecular speed, because of temperature. So slow moving molecules are solids, faster moving molecules and atoms are liquids, and the fastest moving molecules are gases. That's of the three standard phases. Last week, I set out a set of slides that showed there are about 15 or more different phases of matter. Things like Bose-Einstein condensates, fermionic blah, blah, blahs, with fancy names, stuff that we really don't need to consider at the middle level or even really at the high school level, except for maybe plasmas. Anyways, there's lots of phases. We focus on three: solids, liquids, and gases, because those are the ones we see. Unless we want to talk about, like, say, a star or something with plasmas. Not a lot of plasmas in our real lives. Okay, so most of what we're going to do for the remote period is going to be CK12 lessons with some demonstrations. And that's what was assigned this week. 14 was a CK12 assignment, 16 was a CK12 assignment, and 17 and 15, 15 and 17 were the Weber.edu lessons. So I'm going to go ahead and open those up, or open up one of them. You'll see that it's a Google form, and there's a link at the top of the form that takes you to the Weber.edu website. Okay, this is a simulation for atomic behavior. Hit start and turn on the gravity. It doesn't really matter how much gravity you use You can hit the 10x button if you want, or just move the slider all the way over. Either way, we just want some type of gravity, so we've got behavior that looks more like what we would expect for solids, liquids, and gases. Solids and liquids at the bottom of a container, and then gases moving up in all directions. So if I hit the freeze button, all of my atoms turn blue. And I hit the freeze button again, they turn even more blue. There's still a few yellows and reds. Hit the freeze button again. And you can see that this atom right here is falling. It started out as blue when I hit the freeze button, but then changed to red as the atom was falling. That's because gravity has a role in this system. Gravity is changing potential energy into kinetic energy. So if I put some energy back into the system, and I get a couple of atoms that are popping up as gases, they're evaporating up as gases. As they come back down, as the atoms come back down, you'll see that their color changes. And that's because the color is set to speed. The slowest speed is blue, and then I believe it's yellow and then red, or it could be red then yellow. Oh, I think it is red then yellow. So blue, red, and yellow are our speeds. I don't see other colors in there. If there are, I don't see colors so well. So if I hit faster, that means warmer, temperature's going up, and you can see that my atoms are changing order. Changing order means that you have a liquid or a gas. As a solid, the atoms do not change order. They may vibrate in place, but they don't change order. So this is a solid. You can see that these three atoms right here, the order doesn't change. They don't become disorganized. They are vibrating, they are moving, but the organization stays mostly the same. There is some order changes up here on the surface. But not anymore. Frozen everything. Everything is vibrating, but it's a solid, frozen in place. Okay. If I hit faster, I'm putting energy into the system, I'm heating things up, and I'm changing from a solid to a liquid. And we know we have a liquid when the order changes. We start to see swirling, and the first becomes the third, or the 15th, or the 30th. So we're changing the order. If we put enough energy into this system, we vaporize. Everything's changed into a gas. We have a lot of yellow here now, and fewer blues. The blues that you do see won't be blue for very long, because as soon as something runs into it, its color will change from blue to red or yellow. That is telling you that the amount of energy in that system, well, at least for that atom, is increasing. Maybe the amount of energy in the system remains constant, because as one atom runs into the next, the first atom loses and gives away its energy to the second atom. Okay, so we're going to warm things up even more, and almost everything is yellow now. A lot of energy in the system. This is the most energetic system that we've seen in this simulation. Again, if I hit freeze, taking the energy out of the system, and the atoms are going to start falling. Turn up the gravity a little bit. And as they're falling, their color changes. And the color is changing because of gravity. Gravity putting energy back into the system, energy of motion, energy of movement, changing potential energy into kinetic. Okay, that's basically what goes on in this simulation. Now, the first thing kids like to do in this simulation is ramp everything up, try to make everything go crazy. And if you do that, which is normal, It's normal 13, 14-year-old behavior. You get an error message that says you've exceeded the parameters of the system and it's shut down. So you just hit the reset button. All right, go ahead and you put in your name and pick a period number, period 1 for period 5, period 4 for period 8, and then just follow the directions. Decrease the speed of the atoms by pushing slower. Describe what you see on the screen. Of course, I think you have to hit start. Maybe I should add a question that says push the start button. What happens to the color atoms as you hit slower? They're going to change from red and yellow to blue. What's happening to the temperature? Temperature's decreasing. What does color represent? Speed and temperature. So color is speed and speed is temperature. What is the color of the slowest moving particles? That would be blue. Solid, liquid, or gas. What is the phase of the slowest moving particle? Slowest moving particle is going to be a solid. Can you get all the atoms to stop moving? I don't know, maybe. They're going to vibrate though, so you probably should say that they're vibrating in place. I don't know if you can get everything to stop vibrating completely. But just try it. Hit the freeze button a lot and see what happens. What is the temperature scale used for the temperature measurements? Probably Kelvin, I'm going to guess. And you can tell, how do you know this is the answer? If you freeze it, if you make everything as cold as possible, are you getting closer to zero? If you get closer to zero every time you hit freeze, closer and closer to zero, but you never go below zero, then that's Kelvin. Kelvin's zero is set as absolute zero, and you can't get colder than that. Absolute zero is the coldest of any possible temperature, and that's zero on the Kelvin scale. Absolute zero is that temperature where the atoms stop moving. No vibrating. All the vibrating stops. What happens when you freeze the atoms? Well, they slow down. Color changes to blue. What happens to the temperature when you freeze the atoms? Again, they turn blue and they move more slowly. What is the color of frozen atoms? Blue. Do the frozen atoms have more or less energy in the frozen phase? Less energy. And do atoms have more or less speed in the frozen phase? Less speed. This question should be changed to short answer. And finally, what is the connection between molecular speed, which is kinetic energy, and the amount of molecular energy? Speed and energy are directly connected. As the energy goes up, the speed goes up. As the speed goes up, the energy goes up. So they are directly connected. As one goes up, the other one goes up, or as one goes down, the other goes down. All right. Are there any questions about how to do these Weber.edu simulations? Nope. Angel says no. All right. Well, thanks for the feedback. Jenna says no. And I know Hannah has already seen all this because she was in class this week. All right. Then what I want to talk about now is the CK12 stuff. Make sure that you guys are hitting the turn in buttons on these CK12 lessons. So if I jump into one of them real quick, let's see how fast it is. Sometimes it's really slow. I just want to point out where the turn in button is found in the CK12 modules. All right, if you use the link and enter a CK12 lesson, you're going to see about 2 pages of reading with maybe a couple of videos in there, or maybe an animation or some type of app that's in there, some type of game. And then in the bottom right-hand corner, some practice questions. You need to do those 10 practice questions. If you miss a couple, then they're going to give you a couple extra questions so you have the opportunity to get the full 10. And then at the top, once you're done with your practice questions, at the top there is a turn in button. Make sure that you hit that turn in button. It's right here when you're in the module. Mine says assign because it recognizes me as a teacher and it wants to know if I want to reassign this. But hit the turn in button, and that's how you make your points available to me. When you hit the turn in button, I can see your scores. If you don't hit the turn in button, I can't see your scores. Are there any questions about how to do the CK12 modules, how to complete practice questions, or what the importance of a turn in button? Any questions about that? Everybody says no, no, and no. All right, so let's close out of that. Last thing I want to talk about, and we're close to being done. I did this demonstration for some of the students this week, alternatives to salt deicer. The theme of this week is phase changes, going from solids to liquids to gases, and a real world application of this information is using salt to melt ice and snow. Normally, this would be a week-long unit talking about how salt melts ice and snow. We talk about the idea of freezing point depression, and we talk about how freezing point depression plays into melting ice and snow, changing it to a liquid, even though we're still at freezing or below freezing temperatures. Anyways, cities across the United States, especially in the north, I guess, and Canada, are looking for solutions for melting the ice and snow that they have on their streets and sidewalks. They want to melt their ice and snow more cheaply. And the more environmentally conscious cities want to decrease the amount of salt that they're using season by season because salt's not really very good for the environment. It's bad for grass, bad for plants, bad for the lakes, streams, rivers that are nearby because that salt gets washed out into our waterways. Anyways, so cities are looking for alternatives, and cities have tried a number of different things. What it comes down to is what is available to the city and is cheap. So if your city is involved in manufacturing beet juice, then you have extra beets laying around, and you might try spraying beet juice on your streets and sidewalks to see if it melts ice and snow. Turns out it does work. Cheese brine from Wisconsin because they make a lot of cheese and they have leftover cheese brine. Pickle brine in New Jersey because they make pickles in New Jersey and they have leftover pickle brine. Potato juice in Tennessee, and you might think, well, wait a minute, aren't potatoes associated with like Idaho or something? Tennessee is associated with producing certain kinds of alcohols. And it says here vodka and rum is made in Tennessee. I think maybe like whiskey also, Jack Daniels, is that Tennessee? I don't know, whatever. So anyways, they make alcohol in Tennessee. So that means they have leftover potato juice in Tennessee. So they tried spraying potato juice on the ground to see if it would melt ice and snow. Here's a second article talking about alternatives to salt and the different types of salts that you can get at, like, say, a Home Depot. Anyways, then we would do an experiment under normal conditions. You guys would be in class, and we would do an experiment where we'd set up 2 beakers full of ice, and we would put salt on one of them, one of the beakers, and we would put something else like beet juice or hot sauce or soy sauce, or just anything that we have in the cabinet, and see if it would melt ice and snow as well as the salt. Turns out none of it really works as well as salt, but if you can get cheese brine for free or beet juice for free, and you don't have to spend the city's money to buy salt, maybe that's better. Okay, so this last item here, I posted the slides for chapter 2, my lecture slides. And you guys can take a look at some of this stuff and see what we have been doing normally. Most of this is not stuff we're going to cover this time because we don't really have the time. Here's this third slide is all the different phases that science recognizes at this point. Bose-Einstein condensates were recently proven to exist. Talk about viscosity, and then the characteristics of solids, liquids, and gases. Here's a slide about the Weber.edu stuff we just saw. Information about gases. This is actually a demonstration I did at the very beginning of the year, just to show kids something fun in chemistry. But it exemplifies different phases. You have a solid, liquid, and gas represented in this experiment. You have a Venn diagram assignment comparing solids, liquids, and gases. We spent a lot of time talking about molecular structures and how atoms fit together to form molecules, and molecules fit together to form crystalline patterns. This is crystalline solid quartz here, whereas glass is an amorphous solid, doesn't have that real regular and repeating crystalline structure like you see with quartz. But chemically, they're the same. They're both silica dioxide. This is halite, just salt. You see it's cubic. Its form is cubic. Anyways, you can take a look at those slides and see what we'll be doing normally if you're interested. Okay, that's it for content for this week. Are there any questions about any of this stuff? Right, let me turn this sharing off. How do I do that? Maybe I don't know how. I think it's here. It is. All right. Moving. Oh, my cat is next to me and she's sleeping. Well, don't wake her up. Okay, next week. We just have been given new information that says teachers need to basically produce content for every day of the week. Now, in the past, we've been asking A students to work in class on Mondays and Tuesdays, B students Wednesdays and Thursdays, and remote students are supposed to be following along throughout the week and then having meets on Friday. With everybody going to remote, the district is asking that students do school-related work every day, all 5 days. Teachers are required to make contact with their students and also post videos. video recorded content and make that video recorded content available to parents. So that's why I use Screencastify today to record this presentation. What I'll be doing is posting this video recording in Classroom so that you guys have access to it, or I'll put it on the e-learning hub and in Classroom. So I guess what I'm trying to tell you is that there's an expectation for you guys to be meeting with your teachers at least once a day. You know, if you need additional support after, then that should be available. After 12 o'clock, you should be able to meet with your teachers if you need one-on-one help. But there should be more clarity today after school. We have a meeting, all the teachers have a meeting with Dr. Markham, our principal, and she's going to explain to us what's required. And then that's what I'll be doing. I'll be doing what's required. So more information today after 3 o'clock. Should be posting some things to Classroom, and your other teachers will also be posting to Classroom to let you guys know what things look like next week. All right, are there any questions for me? That's everything I have for this week. Nope. People are saying no. Okay, then that's it. If you have questions, feel free to send me emails and let me know that you need some help. If you need to have a Google Meet later on today, just send me a message. I'm available usually until about 5 o'clock every day. Other than that, that's it. Thanks for showing up, and I'll see you guys later. Oh, hey, make sure you fill out your attendance forms. Bye, Angel. See you, Jenna.